Great to have you here.
Yeah, thanks for having me. I'm excited to hear about all of these generative projects, on-chain interactions, and I'm just going to continue with that thread. Hi, I'm Ian. I'm a software engineer at Zora, and I was once called a Telezite media counselor, part-time media artist. Today, I'm applying both of these backgrounds, discussing poetic examples of NFT metadata. NFTs are popularly associated with the JPEG image format. However, the core innovation of the NFT is the blockchain record. Meta here means self-referential. Now, how can metadata formats be poetic? Poetry is the aesthetic and rhythmic element of literature. Here, I want to explore the generative and aesthetic side of NFT metadata. The now famous ERC 721 standard is a minimal specification inspired by a few early ERC 20 experiments. The standard carries the lineage from ERC 20 by focusing on tracking of ownership. It's not designed to be a comprehensive format for multimedia art, but more of a starting point. NFTs are sold as many things, but the metadata is the magic behind the scenes that transforms these lifeless numbers on the blockchain to artworks, characters, and music. This talk, for instance, would have had the metadata of tags, NFT, art, duration, 10 minutes. Not necessarily interesting, but once you include the slides or a video, then you're going to get more context and more content associated with that particular object. Before we talk about poetry, let's discuss the standard for metadata. The standard describes storing only the name and symbol of the abbreviation for the collection, along with an off-chain link for each individual NFT. Including more complex information on-chain is quite costly, and the standard recognizes this by recommending creators move NFT metadata off-chain. The standard only prescribes 3 fields, though, for this on-chain metadata: name, description, and image. And the image is another link to an image-type content. Now, unfortunately, artists often have to compromise a portion of their vision while minting an NFT due to the lack of expressiveness of the current metadata format. Now that we've covered these rigid technical standards, let's look at this from a more poetic perspective, from an artist's perspective. How are these standards applied to crypto media art? A promise of blockchain art is that it can encapsulate technical, complex projects in their native format. Put yourself in the shoes of Ezra Miller, an artist that created a web-native generative artwork this year. The interactive settings for his artwork were determined on mint by creating a random-ish number based off of blockchain data, and then connecting that to a web interface experience. Now, we've learned the standard. Making this token should be a simple way. We just have an image format. How do you express a more complex project on the blockchain? Now, here's where things get interesting. The artists here needed to make decisions to fit the format and rendered their code as images to fit the contract. That's not very poetic. And you can see here, there's a video of the NFT in some cases. How does that work? Well, OpenSea has added a few custom fields that they understand on top of the standard. One field in particular, animation URL, is especially useful. Let's go download the metadata for this piece and see what it says. Right away, we can tell there's a lot more fields than what you might have expected given the standard. And that is the living standard you see. You can see there's a link to an image, description, name, and there's attributes. Attributes are often used for filtering, and they're useful for rarity. They power a lot of the rarity tools, and they're very flexible. You're going to see them as filters on most platforms. And then you have an external URL, which is the site the artist intends you to look at the artwork on, and an animation URL, which in this case is a video. It's not an interactive NFT, but if you go to the artist's webpage, you see the interactive NFT. Now, the animation URL is kind of a catch-all, which makes rendering pretty difficult, and you can't describe as an artist more specific information about how the data should be rendered. Now, what's a more elegant provenance for these interactive NFTs? How can you make them more natively on-chain? Solvency does include a custom field, loosely linking its code to a smart contract for provenance, with the hope that someone could rebuild a piece many years later. But a step ahead of this is including the entire source code needed to render the token on the blockchain. Artblocks is a platform that does this. A key part of their code is also generating a unique hashed-in for the artwork, but there also is an on-chain element. And that on-chain element is a copy of the JavaScript code recognized by your browser to render the NFT. Artblocks popularized this concept, creating a stronger provenance for generative works and introducing more constraints for artists. This feels poetic, taking a limited standard of technologies and creating new primitives. Even with these limitations, artists and collectors can embrace creative solutions. Still, we have one issue with the provenance for generative NFTs shown earlier. There still needs to be a centralized server to assemble all the pieces to render the correct metadata for an NFT. This is the case for art blocks, this is the case for solvency, many other projects. Now, while ownership does provide a type of provenance, it's only one-dimensional. For NFT media to be effective as a lasting artwork, permanence and mutability need to be addressed. Mutability is a primary concern of digital art. Rather intentionally or unintentionally, the data that makes up the artwork can change or be destroyed over time, whether machines don't recognize it, or the files are lost, or they're improperly copied, etc. Centralized servers have all these issues. It is one place to look up, and it can go down. It can be modified. It can be changed without the artist's intention, perhaps, or the user's intention. Now, a solution for this is to use a content addressable hash. And a good example of this is the interplanetary file system, where the link to the content is described exactly by the content itself. If the link changes, the content has to change. However, we still have another problem. IPFS, or interplanetary file system, still requires a copy of the data to be floating around on the network. There needs to be a server keeping it available. Airweave is a solution that is another blockchain that handles file permanence. As long as that blockchain is around, all the files uploaded and stored on that blockchain will continue to exist. Now, you can also, in a more poetic way, return data about the NFT from the NFT itself. The standard, however, requires an off-chain link. Now, to get a link off-chain, it has to go somewhere else. But there's this part of the link standard that allows you to embed the content for the link itself in the link. A little self-referential, but it works. And it allows for smart contract code to generate not just the metadata, but also the metadata and the content of itself. So as long as you have the provenance of the token on the network, on Ethereum, for instance, you're going to have the content of that NFT described in the metadata from the same place. The earliest example of this is the Autoglyphs project by Larva Labs, the creators of CryptoPunks. They put the data directly in the URL of the token for Autoglyphs. And people have since then created derivative projects that just call the contract code and then do transformations on it and then return a new token that looks entirely different, but the basis of it is exactly the original text used to generate these tokens. These sorts of playful on-chain interactions have become popular with a trend of open licenses for NFT generative projects, allowing for remix and creative derivative projects that are not disallowed by the creator. The Nouns project is a fully on-chain generative SVG profile picture project. SVG is a format of a picture that can be very compressed, and it's used well for drawing. And it's auctioned off every day. Since the code that generates the image lives on the blockchain, takes a number, returns an image, you can just pass it another number. So people have created derivative works, as we can see on the left, which are their own interpretations or their own ways of bootstrapping a community using nouns. The middle project is called Blitmap by Don Hoffman. It's encoded a simple bitmap. A bitmap is just a set of pixels. But the bitmap has a separate data for color and a separate data for structure. So you can take a bitmap and connect it to another bitmap and get the colors from one bitmap but the structure from another. And that is how Dom minted that entire project. On the right, we can see Generative Transfer Project, an SVG on-chain project where the color is determined by each owner of the token as it's transferred through the network. And you can see that somebody took a lot of effort to make something that looks nice. While working around constraints can lead to fascinating results as seen above, there needs to be more inclusion for rich media formats and creators on the blockchain that are not as technically savvy. And incorporating and documenting current standards and thinking of new multimedia standards that are more flexible is highly important. Zora recently released a library called NFT Metadata that normalizes existing metadata and allows for a mix of on-chain, off-chain data to do this in public. I want to thank the Ethereum Magicians for being a really good resource, documentation, and community for this. And looking ahead, I'm incredibly excited to see poetic uses of metadata standards and what's coming in the future. Thank you so much.